Hello and welcome back to another evening of Rust with me, edA-qa mort-ora-y, your host. Today we're going to be doing Bomberman again. We're going to be doing optimizations, and for those of you who've never seen the show before, we're running in Rust language and we're working on a site called Coding Game. Coding Game where we have several challenges and all we're doing is writing robot bots. We'd like to start the show with something called Clash of Code. We're not really very good at this, but oh, and there's not much time left. Clash of Code is a quick challenge, and it's not really well suited to Rust, but it's okay. Or not suited to me. There's a code golf on it, which I actually don't like, but it's more peaceful than the other ones. There's the reverse mode, which is kind of good, and then there's the fast mode. Fast mode is when you just have a piece of code and you have to code it as fast as possible. And I don't know any of these people today. Johan, Bitwolf. And we're going to see, and right after that, we're going to get over to the robot Bomberman. I think it's called Hypersonic here, and we're going to see where we were. Yesterday, we were just leaning on the edge of silver, and I got a nice surprise for you there, what actually happened there. And today's going to be all about optimization for speed, not algorithmic, I guess algorithmic, not in terms of like the way the bot performs. The bot's going to do the exact same thing. And we've got to make it go a lot faster, because we're doing a search. We're doing through a search tree, and we need to pump up the depth of that. We're only going down 2 in the tree, and we're going to need to go down to, I think, down to 5 to compete at the top levels. We might only need to go down 1 more level to get into Legendary, though. We're going to find out. And this is going to be Rust optimization. We started doing benchmarks yesterday, and we're going to see what we have to do today to get further. Feel free to ask questions at any time. Feel free to cheer for me in the Twitch channel, even if it's just 1 bit. I just like having names up there. They're fun. And do share my show. It helps out a bit. And let me know what you like and don't like. And while we wait for this, I'm just going to think of random things to talk about. I'm going to open up our GitHub website. And this is where I list the code and tools we're doing, a little bit of where stream is, and the tools we use. We use an external editor, so we don't actually edit in the site. For this Clash of Code, we do edit online. It's a terrible little editor, though, but it's quicker than setting up the external one, and for the speed ones, that's important. And we're using Visual Code for the actual Rust editing. We use the RLS plugin, but it's horribly broken. Maybe today we'll figure out why it doesn't work. And if I can quickly figure that out, that'd be great, because it was really helpful, and it's not. It's just broken right now, unfortunately, and we don't know why. Alright, so we've seen a lot of people come and go in this Clash. I'm not sure why, and we're going to find out. And although I'm actually getting kind of tired of playing these clashes, we're going to play them a little bit longer. It's a decent way to warm up the show, I think. Help get people into the show. But I'm getting to the end where I don't know how many we do. We have 4 players. That makes it harder for us to get to the top. 8 players is usually good, because it guarantees like several at the bottom usually. Alright. Here we go. What are we going to do today? Reverse mode. So we see input and output. We have to guess what happens. So we see this, and we get this. And we don't have an algorithm, we just have to get these results. And we have to figure out what it's doing here. 6 to get to 410, 15 to 310. This one here is really curious, so it's a negative. And this one starts with a 0. Oh wow. This is really wacky. What on earth is the thing here? 6 to 200. Well, I'm going to open up Octave and start playing with commands. So we have this output 210. 210 divided by 6 is 33.5. But that was 200. Got the wrong number. 35. How does that feel right? 235 divided by 4 is not that. What if we do 1 times 2 times 3 times 4? Times 5. 5 times 6. 720 divided by 4? 180. So that's not it. The zeros and the negative are really kind of weird. What on earth could this be? Wait. These numbers here. This add up to 11. Ah, this is like 6 minus 4 and 4 plus 6. I get it. I get it what's happening here. So we have two numbers here. And I think the answer is, we're going to pack these numbers together, and what we have is A minus B and A plus B. That's what it looks like. And this is actually a play all button here. You just can't see it because I got it zoomed in. And let's see if we got the right answer. I think we have it. So we're going to submit this. Oh no, no! So, some guy just came in ahead of us. Terrible, we were first. Come on, no, no. How'd I hit submit before being overconfident? I was just letting the test run through, and we lost by 3 seconds. But that was interesting. But this is the thing about the reverse ones. The reverse ones are a little bit weird that you either get it or you don't. There are some that are kind of hard to do, but mainly they're just you get it or you don't, and there's some wacky ones in there. But this one was actually fun. This one was perfect, I think, for that. And who knows about the test cases, I think, had good relevancy here because we could see them all. Usually we don't see them, so I don't comment. And he came close behind us. In Nipat Jinsu, I say there's no reflection of how good you are at anything here. It's really a matter in the reverse ones of whether you see it or not. Alright, so let's move on. Let's check out my level. We got up a little bit level here when we played the contest. We didn't get as high in this contest as the one before it, but overall our rank is slowly improving. And I guess we're here, we're rank 1381. I'd really like to break 1,000. I think that puts us in the Grandmaster mode. We're at Master. And I think that's just as we finish more contests. We don't really have to aim for that. As we keep doing more competitions and contests, we're slowly going to get up there because it's based on points and we're just being an active player. And the multiplayer stuff down here, there's tons of multiplayer stuff that we haven't done yet. So there's lots of games we can just keep adding to it here. The Clash of Code, you can see it drops really, really fast. And that's because we're in the top 0.1% anyways. And it just has like a decaying thing, so we lose that pretty fast. And if we keep doing it, we keep going up, but I'm not so interested in doing that. And I don't think it's making a huge difference at the top of the ranks anymore anyways, but we're going to see. Alright, let's go back to competition here. We were doing Hypersonic. And for those of you that were watching yesterday, you'll notice that this is now gold. This is no longer silver. We actually managed to sneak into the gold league, which is really good. So let's join the game and let's see how we perform. Alright, we're going to play a game against the... Let's play against the AI boss and see how we do. So we're 120 of 192. We're going to play the AI boss and see what happens. We lose against him, that's fine. We know that. So we're up here, he's down here. And obviously my bot doesn't do ideal things, and this is what we're going to fix today. It looks like I die in this one. Yeah, I don't even make it to the end, so I get trapped by some bombs. That still happens, and that gets really hard to fix. We should avoid corners, we should avoid dead ends. That would be the safest thing to do to avoid getting killed. But that's not what we're going to work on today. Today we're going to work on optimizing to do our search depth and hopefully figure it out on its own. You can see down here is the command output. Regnagas, yeah, I got to gold when I was offline. I just got an email overnight and I was at gold, so... Yeah, I'm streaming early today. I'm actually thinking of actually starting streaming more along this time because it's been too often. I'm way too tired in the evening. We're going to see though. I have a bit more time. I'm going to probably stream it this time and I'll probably keep doing one later at night. I'm not sure which day. Alright, so I got trapped there. It's kind of silly. Actually, it looks like I made a mistake. Oh no. See, so the reason I got trapped here is because right now I can't move. Because this bomb here, I track this, it's going to make these all go off and set this one off. And you can see that right here, it's all red. So this was my safe spot. But the problem here is now is this 2. Now, it's too late to move away. And I'm dead. But okay, we're going to work on this today. We're going to work on the optimization part first. And That's all we do because we don't have a clear strategy approach here. We're at 120 of 192, and let's check what that is on the leaderboard. This is a score of 15.61, and the top score is 24, as it usually is. It sits around 24, and that puts us really far behind. There's a steep curve here, so any heuristic changes are not likely to help us at all. And so edA-qa is asking, No, I'm not actually counting. I'm not counting what the enemy bombs do. I'm not considering that if an enemy bomb goes off, I don't count it towards my score. But that's really sort of a yes and no I am. Because that's where the depth is going to come in today. If my simulation actually has his bomb explode that first, I won't count that towards my score. It's only when I'm doing my leaf node. When I'm doing my leaf node calculations, I don't consider his bombs. But the biggest advantage here, the biggest thing we can do right now is just increase the depth to which we search. And that'll give us the best chance of actually scoring correctly. So we have a lot of shortcuts now based on the fact that we don't go very far on the tree. The further we go on the tree, the more and more we can back off from those shortcuts. And so like I say, as edA-qa says, we're doing a simulation, and what that means is that I'll tell you a bit about how the robot works. Let's take a position right here. Where's one place we place a bomb or where we move? Where's that last bomb we placed? Let's go right to the start. So every time we want to take a move, we evaluate. We go through all the possible moves. So at any point in the game, I can move up, left, right, or I can place a bomb. Technically, you can place a bomb at the same time you're doing all of those, but we've simplified. And what the game does is we do a branching thing. We start looking. Well, we say, what happens if I go down? And then what happens if I go right from there? And then what happens if I go down from there? And then we score it. We go down to a depth of 3, and then we estimate a score based on where our bombs are, who's going to die, and not where the enemy is. And then we sum up all these things for each branch, and we take the branch that looks the best. We take the branch that says, hey, this one looks like the best option. Let's do that top level move. And what we're going to go down today is we're going to look further in that tree, further down looking for moves, and then because that's going to give us the best option of what to do. And there are some things to do with it, and this is just the thing. We got 2 of 4, and that's fine. And you can see that I was promoted to Gold League yesterday. So let's start looking at the code. Now, unfortunately, we're going to leave this pretty graphic behind, and it's going to take a while before we can actually make any progress in the game itself, because we have these benchmarks we wrote yesterday, and the benchmarks are showing something pretty extreme. Oh, and I don't remember, I don't have my benchmark code in here, so I think it was clear and cargo plus nightly bench. Alright, and this will give us the benchmark results. A big issue in the approach we're doing is in the code. I'm going to look for a .clone here. When we iterate through the states, right here, get my best turn, we iterate through the states, we call a clone function on the state. And this clones the state, and then we apply a turn and step, and so we keep mutating a new version of the turn. But cloning is very expensive. I mean, it's not... In terms of very expensive, you have to remember when a tree, we're going to get up to thousands of moves, so everything you see is times 1,000. So even though the value is down here in nanoseconds, again, multiply by 1,000, and then you have to multiply multiple operations. We're also running in debug mode, and that's really shitty for doing performance tests and stuff, but that's the way coding game is running. Their games run in debug mode. I was never sure why they did it. It was probably initially a defect, and to change that now gets a little bit complicated for the ranks, because they're going to screw up all the ranks if you suddenly change everything to release mode. A lot of bots are going to get better scores, so it's kind of challenging. How do you change that? But they said they're going to look at it this year, and I really hope so. Because writing for debug mode, especially optimizing, is really, it's like way up on the list of stupid things to do if you're doing a project, right? I mean, the best optimization is to turn on release mode. Because these numbers here are a lot lower in release mode. Alright, so let's check what we're looking at. We had the state clone function, And this is the basic clone. So this clone here, when we call clone, is taking about 420 nanoseconds. And that may not sound like much. Again, multiply by thousands, and we have other places that are cloning. And then you notice we wrote a function called better clone into, which takes 90 nanoseconds, which is a huge improvement. This is a massive improvement, and this is one we're going to address right now. How can we avoid all this cloning? But the benchmark I want to set up first is let's benchmark this entire getMyBestTurn function, because this will help us make a pure decision as to whether we're improving or not, because this does a lot more things. Because isolated state clone improvement will help a lot, but that's only part of what the thing does. So let's get away from here. Let's go over to miss, and now we're going to do a benchmark for function getMyBestTurn. We were also going to look at another benchmarking tool, but I want to get this running first, then maybe we'll check out the other tool. I can't remember what it was, but it's in my list somewhere. And no, if you guys remember from yesterday what it was, I think it's in the bookmarks. Bookmarks are so big it's hard to find stuff though. Oh, let's just go and see where it is. Recent tags, recent standard Rust. What do we do? Other bookmarks right at the end. There it is. No, not that one. It's not right at the end. I just bookmarked everything. Damn it, I don't know what it is anymore. Huh. Criterion, that's the one we want. We'll get back there. Alright, so getMyBestTurn. The issue with getMyBestTurn is I can't really just give it a empty state, because that's going to do some weird things. So we're going to set up a state with boxes on it, and so let's put the boxes in odd lines. We're going to say box y times 2 and x times 2, and this will set up a grid of boxes for whatever reason. And then we're going to set up some walls as well, because the walls influence the thing a lot. And we're going to put just the typical wall pattern. Ah, man, I really hate the online Rust docs. They haven't done usability tests, because they put these massive area where you skip pages, and every time you try and click on the window. And so the box pattern, we're going to follow exactly their box pattern. It's or wall. In the middle segments, everything is a wall. And I'm going to see how we set that wall. How do we set a wall? Maybe we can't directly. Cell type. Well, we can set wall. We'll do it that way. Okay, this. And we're going to totally load it up with boxes, because that costs a lot more. You see, this thing's totally loaded up with boxes at the start. And the start is where it can be costly as well. And we have 1, 2, 3, 4, 5, 6. 6 and 5 rows. Alright, and we're going to do state dot grid dot set. And I forget how I call set dot set position. I point to at, we're going to say x times 2 plus 1 and y times 2 plus 1. And that's going to be what are we setting? Cell type wall. And then we're also going to add a box. But we want to add more boxes. We want to add just a whole bunch. Just boxes everywhere. And trying to think of how we do that. We can add them in sets of 2. Alright, I don't think it matters where we add them that much, as long as we have some spaces and stuff between them. And alright, let's just take them and go add a box at x times 2 and y times 2. because this is +1, so that should be fine. These will never overlap. And let's add a box right beside it as well. I'm going to add 2 boxes. And this is going to really increment the cost a lot. And we're also going to put a person down somewhere. And where was that in the test cases? So we added a person here somewhere. 2 good bomb, person, person, person. We added a player here, and let's add a bomb as well. Let's take this. We had a parsing function, but I just want to make this a little bit more generic. Don't need to parse that. Let's do that. And the player is ID 6, and we're going to add him at 0,0. And this is his bomb stats. He has 1 bomb and 4, and that's fine. And we're going to put another bomb at, I don't know, let's put it close by. Actually, let's just leave the bomb out for now. That's fine. That's fine. Let's just leave it out. And what we have to do now is we're going to do b.iter. And we want to call one function. We want to call the function get my best turn. Okay. Yeah, Reknakus, we're gonna do that as well, but I'm gonna do the benchmarking first because we really want to do this locally and we want to get good benchmarking results. Because if I have to submit every time, that's going to be really super slow to do it. Strategy, get my best turn. And this is and state, and I need a strategy. Where do I create a strategy? Strategy new. That's reasonable. Let mut strat equals strategy new. And I don't even think I need that. I think I've just imported everything. Use Hypersonic strategy star. And mut strat. Alright, let's see if this actually compiles. Anybody know how to run just one of the benchmark tests? That'd be really helpful. And whoa, what have I done wrong here? Oh yeah, we're gonna have to put this into the strategy namespace. So we're gonna have to do this, take this out of here, just say use that. Hello, Cries. Welcome back to the show. We made it to gold. We're at 120. I see you're way above us now. Hey, but we can play Cries now. Cry. There we go. You're 29. Let's see how we perform against you. Cries joined us when you first did the show, the first Bomberman. He thought it was so excited he joined in, and he quickly surpassed us when his code and went right to gold and left us far behind. And I beat him! Yay! We're not as good as Crysbot, though. Don't let this one victory fool you. It looks like he got trapped in the same type of bomb. We're going to figure it out, but I'm guessing he got trapped in a bomb situation like we often do. Because if you don't consider the other player, there's a really good chance that when you get close to the middle that you just accidentally get stuck in a bomb situation you can't get out of. Because Cries is destroying more boxes than us. And so if he didn't die, he'd probably come ahead. He'd probably come ahead, but let's see how we die in the end. We're doing pretty good here. He's still got a box lead, so he's got 24 to 19. He's getting more boxes than me. And we're stuck on top of it. And so, yeah, that's just it. He just got trapped right there. But who placed that bomb? Yeah, I placed that bomb, and this is what I mean. If you don't consider the other people, this is going to happen. So his bot more than likely just ignores me, And I completely ignore him too, so the fact I placed a bomb there was just sort of dumb luck. Well, not dumb luck, I would have placed a bomb there, but it has nothing to do with his bot being there. And so he just happened to walk the wrong location. Probably because this is a good spot to place a bomb. And I'm not clear why I didn't walk further. Let's play him again. Oh, so Cry's won this time. And it looks like you won by score. Let's speed this up here a bit. Let's put this up to ×2. Let's throw this up to ×5. Let's watch what happens to these guys. Bomb, 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 bomb. And so Cry's wins by 3 boxes. So, and since Cry's is number 29th, maybe we're not that far off, but I don't have a simple way to get more boxes. We're just going to do the optimizations anyways. Let's try it again. Our current logic is super conservative. It really worries about just being safe rather than getting boxes. And so I don't die again here either. So it must be a box thing again. And I just don't place boxes very optimally. And that's partially to do because of the depth. Our depth searching would improve that. And again, 24 to 29, 6 box lead. Oh, so Cry says he's not doing chain reactions. Do you have a scoring function? Do you have a scoring? Because our scoring function includes chain reactions. But our scoring function doesn't really consider it. And so it looks like we only beat Cry's when he dies, when he gets trapped somehow. So your bot is a little bit unsafe, but doing well otherwise. And yeah, so you disintegrated again. And that might be the chain reaction thing if you're not considering chain reactions. But you're definitely getting more boxes than us. Yeah, we've got one of those too. Every time our strategy, when we have no target, we figure out where we want to go to, and then we go there as priority. And our bot right now does a lot of suboptimal bomb placement because I'm using scoring. So I'm guessing Cry is just saying if you're not doing depth searching, you're actually just picking a key location, placing a bomb, then picking another one, placing a bomb. Whereas mine, I actually pick a location I want to go to, but I'll drop bombs along the way as long as it looks like the score is better. What that creates for a problem for us is that when I get to the place I want to place a bomb, I may not have a bomb left. And so I make a lot of suboptimal bomb placements, which costs me in the score, but opportunistically gets me more things. So if we do a longer depth, that shouldn't be an issue. And if we actually try to get more of these items to improve the number of bombs, shouldn't be an issue either. But I had so many of them, I mean... I'm getting dragged by every... Alright, so you're like scoring where the best place to drop a bomb is? Is that what you're saying? That would sound something like what we're doing. We don't describe it that way. But yeah. Alright, so we have that, in any case. I'm happy we can... No, we don't... What do you do then? Dragged. We're going to eke out your secrets from you. I think we know what we're going to do, but... It's going to be similar in the end, I guess. We're scoring. Somehow you have a scoring and you have to figure out what's going to happen. Alright, so here we are, and we did get best turn. So now you can see a problem in our test here. Get best turn. 1 call of this costs... Well, this is odd. It's saying it only costs 7 microseconds. Alright, Cries, I can understand that, yeah. I think it ends up being somewhat similar, but a different approach to how we're doing the flood filling. Now, this number coming out of our benchmark is worrisome. It's too low. I was expecting this to be a lot higher, so our game board does not appear to reflect a realistic game board. And that might be because of the start of the game. So let's just go somewhere right in the middle of the game. Let's go here and let's copy this game board. We can actually copy these things in. That's where the parse function comes from. State.parse, and how did we do that? Okay, now there's a few things we can't parse. We can parse, I think, just x's and walls. And 0. What was 0 again? Let's figure out what the parsing actually does. Parse. What do the parse things do? Parse. Dot is empty, x is wall. 0 is a box. Good, we have boxes. And lots of boxes. Good. And this is an item. A dot is an item. It doesn't matter which one it was. And so that's all we have. The things that we cannot add are the stars. And the stars are bombs. So we're going to add bombs for those locations. So we can get rid of this stuff here. We're just going to actually parse this in. Where is my other exclamation there? Oh, we only show ourselves. So we add the player, and our player is at point 4, 0. And we have 4 bombs. I don't know what happened there. 4 bombs. The range of 4. So we can get rid of this thing here. That's replacing that. Dot. Now these are bombs, so we're going to put some bombs in. State.addEntity. There's really no easy way to encode this in the output. I mean, we probably could make a way to actually encode this, but as we get further, we might want to actually encode the full thing better so we can parse it here. But we'll just live with this for now. Entity type bomb, and this has an owner ID. These are our bombs, I think. This one, at least the first one. I point 2 at, and this is at 3, 2, 3, 2, and these both have a range of 3, I think. That's a timer of 6, so it's going to be 6. Actually, which one was that? Which one we... Yeah. It's a timer left of 6, and it has a range of 4. And there's another bomb at 4, 2, and it has a timer of 7. And we have another bomb at 2, 4. 2, 4, and it's got a timer of 3 on it. It's got a timer of 3 on it. Let's pretend its range was still 3. Okay, so those are my bombs, and the enemy has 1 bomb as well. We'll say the enemy has an ID of 8. Doesn't really matter here. And his bomb is at, where is this? 9, 8. I think it's 9, 8, yeah. 3, 2, 4, 2, 2, 4. 9, 8, 9, 8. And it's going to detonate in 8 turns. And I think his is also still a range of 3. No, it's a range of 4. So those are all the bombs. That's a more realistic setup. I can replace those with dots. Dot, dot. Dot. And that's all. That's the state now. Now what I'd like to do is somehow, does anybody know how to run a specific benchmark? Let's look that one up. Rust run particular benchmark. Let's just run for Rust benchmark. Alright, get my best turn. No benchmark named Get My Best Turn. Get My Best Turn. Well, that's unfortunate. There clearly is a benchmark called that, but it doesn't believe it. No, I think the option's right, but why is it not finding that? Why is it not finding my benchmark? Because the option definitely appears to be right. What if I take off this bench? No. Huh. Well, that one kind of sucks. It can't find it. Why can't it find it? Is it just called miss? Is that the still? Oh man, that's kind of sucks. So I can't run a particular function, or can I? It runs only the target. Can I do this? Get my best turn. Let's try it. There must be some way to run it. Come on, let me run it somehow. No. Well, come on, I want to run just that one. I don't want to comment all the other stuff out. So bench test, dash those tests. Get my best turn. What happened? No test target. No, so you can't do that. You can only run a particular lump. That's stupid. That's really unfortunate, too. Well, then let's switch to the other one. Let's switch to the other test runner and see what happens. But you can see now with a real state, and this is what's really curious, we put the game in a real state now, and look at how long it took to evaluate that move. Yeah, Cries, it worked like that for test. The test was a function, I think. It wasn't a package. So it does seem inconsistent there. But in any case, we can see this, that our time for get my best turn is pathetic. This is high. And putting the search depth down 1 probably hurts it a lot. So just for comparison, before we switch benchmarking tools, so this is what the depth of get my best turn. You notice we have a depth of 2 right here. And what we want to do is we need to get this to 5. And we're at 2. And watch what happens when we get to 3. So look at this number here. We're at 400,000 microseconds. It's like half a millisecond. And when we put it to 3, we're going to see that number probably jump up to ridiculous amounts. Or it only doubled. That's weird. Now, what this is indicating, and this may have a huge variability, and this is like a big problem. It's Alright, that one works. I don't remember. I don't remember for test what it was, but I thought I put a dash dash test there, to be honest. I don't know what the difference in dash dash test and just specifying it is. Alright, so I think the coding game site is really slow because when we put this to 3 we timed out, but not at the start of the game, it was a bit later in the game. But let's put this down to 5 and let's see what happens there if we go to 5. Each one down should double the time, so we're expecting 2, 4... Well, this is really odd. That's only 8 milliseconds. And we're in debug mode. This is definitely debug mode. Let's double check this though. Right, we have an op level here. This is our profile bench. It's in debug mode. I think we can comment this all out. And let's check what happens if we go up, if we do this in this release mode now. I think it's the maximum time we're allowed to have, I think, is 50 milliseconds. 100 milliseconds even. Alright, then there's something really weird here. Alright, this is not doing debug mode. Is this op level 1 probably too aggressive? No, there's something clearly wrong here. Because watch, if I actually build this one, clear cargo build, and submit this one, we're just going to time out. So I didn't time out. Let's try it again. I died, but... I have a feeling our searching's not doing very well. Am I not saving that file or something? It made no improvement in the game, which is concerning. I think I have some error here. We're going back too early. Alright, that's taken a bit longer, but I don't think our searching's doing very well. Unless somehow we've magically improved the time. But the fact it's not improving the game is what bothers me the most. Well, now it's taking time. Well, I compiled it so I can run it again as well. Yeah, there's something wrong with our searching, because I'm at a search depth of 10 now. And there's like no way I can actually do a search depth of 10. And it's not improving anything. So I've got something wrong here, and... because that would be awesome if we can get to 10. We can't. Let's get rid of this one here. We know that's done in the other one. Or or Cry's bot is that good. Just to check this out, let's submit this one. We should be seeing timeouts, or there's something wrong with our code, because we set it to 3 before, and 3 we failed on. But we may have made changes to the code that optimized it since then. Maybe there was something really slow that ran before, and that would be really nice, but I kind of doubt it. I kind of suspect we're just going to start timing out. Alright, we're going to go up. We've got a nice set of... we've got a whole bunch of errors here. We failed pretty fast. Let's just let that run and see what comes out of that. And this test is still running, so clearly the iteration is causing an issue. Like, it does take longer. And based on this machine here, there's no way we can actually get to 10. Which means we tend to be pruning a lot. And in real situation, we're probably pruning. And let's look at the ones where we're losing. We're probably losing because we timed out. Let's find one here. No. This interface really sucks. I really wish they'd improve this. And... Well, we don't die. We just don't get any bombs. Oh no, this bug again. Let's go up and show this one. Alright, so we disintegrated. Disintegrated. Huh. Alright, so we have something weird, that this iterate best turns is not actually doing anything. Let me just remove this bit. I can trigger that heuristic. What on earth is causing the issue? Iter best turn. We're canceling out too fast. If likely die, we return none. That's the most likely thing that we're canceling. Although it's the test here is like, look, this took almost 1 second, so that'd be too long. And but why is it going so fast? That's the issue. It should be going a lot slower than this. Now we take the best score of each one. We should probably be taking the average score. I'm not sure on this. Average score might make more sense for iteration rather than best score, but hey, let's just I don't believe iteration's going this fast. This is what's really bugging me. It just can't be going this fast. No, 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 no. Why? Or maybe... Pwah. That's just super weird. I don't understand what's going on now. Let's do get my best turn. Like a depth of 10 should give us... Yeah, right now because I'm having problems, my code is too fast. And the issue is that I wouldn't mind it being too fast, but the search depth of 10 here isn't improving our game, it's making it worse. And why would that be? Iter best turn. Something unintended changed. Let's put the bombing back in for each one. We can bomb whenever we don't move. Yeah, Recnactus, that's insane. That's why I'm really wondering what the hell is going on. Well, we win here because he dies, and we know he does that sometimes. That's not really a new success there. What could I have possibly changed that made it go faster? Alright, Cries, we'll see you back in a bit. We're gonna figure out how to beat your bot. Alright, we only lost by 1 box that time. That's kind of annoying. Wow, we tied on this one. Two against two. One against one, I tend not to die. I'm pretty good at that one. I don't know why, because I didn't really consider the bombs. And we are placing lots of bombs now. We're just not particularly choosing a best approach about it. Like, we only lost by 2. Well, let's submit this one. I can't believe it's going this fast. We did something, and the fact that we're not doing better, it's also kind of weird. So in this one, they just die. And let's take this one where we lose right away. What happens here? And this one, we just don't have enough boxes. Rekonaka's, I don't, it seems hard to believe. I can't really, it seems ridiculous that we'd be going to a depth of 10. But we're not dying. So our scoring just appears to not be so good. Weird. So now, Rekonaka's, I really don't know what the hell is going on, because our score's getting worse the further we go deep. That's weird. Let's check some of these things. Let's go back to those last battles. And let's take one where we lose. Like this one where we lose badly. Yeah, Petrosol, something's weird. Can you confirm, though, that maybe what I'm doing is I'm taking the best score, and that may actually be a problem. I should be taking the average score for the branch. Is that correct? A branch should take the average score, not the depth, not the maximum score. This is the change I'm going to make now, is that I'm going to take the average score of my search tree, because right now I'm taking the max, and that may be unfair because I may be getting greedy, and I should be taking the one that has the best average score, I think. I don't know. Oh, and he just says he's taking best score. Then maybe my scoring just sucks. Alright, so what happened here? And there's some randomness because I did different things. I'm just looking for the score outputs here. We clearly are making decisions. Yeah, I think I'm going to have to actually count the depth, count the number of turns. Because 10 is like ridiculous. There's just no way this is 10. So let's do iter best turn. We're going to actually count the number of iterations we do. Iter best turn. We're going to give it a count and mort-ora-y. And count. And we're going to do this times this. Count, and we're going to update the count. For every time we call it or best turn, we're going to do count plus equals 1. And this will tell us what our depth goes to. Alright, that's down here. Count. Cannot use... Oh, I hate these things. I dislike Rust's sort of weird, you're kind of a pointer but kind of not system. Or maybe I can just do plus equals 1. Alright, now we're going to submit this again. We're going to look at how many counts are. Our rank did jump though as we played more, which is weird. We might just be getting lucky there though. Ah, see? Now it's going back down. We tied for first place. Alright, just pause it and let's look at the counts. Yeah, we're not uploading new code. That would be the main issue. Alright, so our connection is not working. I must have reloaded at some point. That would be the clearest explanation of why it's not uploading, is because we're not using a new code. So I've just kept submitting the old code. Wonderful. So now I'm expecting a timeout. And so I timed out like immediately now, and that's what I'd expect. So we're playing Petrocell and oh, we die. I don't have to point out my mistakes yet. It's your wrong code. Yeah, that's very much it. Just, I'm not uploading this code. Alright, so we get a timeout now. That's what we expected. But what's concerned me now is that, let's go back to that. Get my best turn. Let's put this back down to 3. Alright, we just have another timeout here. Yeah, so we have another timeout. And let's look at my iteration counts. So you can at least see that we're doing a lot now. And here's the iteration count, 243, 48, 129, 215. That's a lot of iteration counts. And let's look at the one where we die. We don't have that many. Right, here's a 215, so we must be going far enough to actually do a breadth of 215, so it's definitely getting iteration counts. And there we died, because probably one of the branches took too long. And this is what I mean, though. What I'm concerned about this, though, is that our branch thing I'm looking for something more fundamental than that because I think our depth would work. The issue is that right now we're relying on pruning too much. That basically we get lucky. Sometimes depth of 3 it works, sometimes it won't. And what we want to focus on now is actually just improving enough so we don't have to cut the branches. But this is where I'm concerned that our local benchmark is not calculating the right thing. Or we're so far out of skew from the server. Because our local benchmark is saying 12 milliseconds. Are there servers so slow that they can't run 12 milliseconds? Like, I mean, this is not that long. Or do we just hit situations where it takes longer than that? And I think it's because this profile bench is not actually working. Because I put op level 3, debug false, and then run it again, it should be a lot faster. Yeah, Rick Nakas, that's one of my things I think. But this is my concern here is our local testing is that somehow, whatever this profile bench is doing, it does not affect bench. It just doesn't affect this. So we have to find some way, the other way to do the benchmarking because we're doing a optimized mode here, and that's not what I want. How do I run a benchmark in non-optimized mode? No, because that's correct because it's really not, it's like I say, Petrocell may have lots of optimizations he can offer us later, but right now our iteration is so damn slow that we can't even think, well, we just have to improve the speed. But what I'm trying to figure out is how can I measure that speed locally, because clearly we're measuring a debug, not a debug mode. We're measuring something that's somewhat half optimized. And I don't know how to run profiling in debug mode. Can I like stick a dash debug here somewhere? Bench options, bench name. I just want to get this running in debug mode. So he says it goes profile dev. So what's actually happening here? Let's see what happens. It gives us an output here somewhere apparently. But we don't get the same outputs. Release optimized targets. How do I change this? How do I change the target for Rust, for the D? I do not believe there's a way to run a cargo bench with a debug target. Well, that sucks. Anybody know how we can run cargo bench with a debug target? Let's check out the Criterion instead. Let's install Criterion. Getting started. Criterion RS. And it offers a debug target, so that'll do what we want, I think. Oh, this is debug output. No, that's what I want. Alright, getting started. Dev dependencies. Let's do that. Criterion equals 0.2. And why is this a double bracket, double bench? Name equals, I don't know, my benchmark. I hope this is all I need. Harness equals false. I don't know why I'm typing this, I'm just following their instructions. Add a benchmark. Where do we have? We'll just stick this to the top here, up here. Macro use. I don't know about that. And what do I need to do? I need to do a... It's a little bit weird. So let's take these things out. We're just going to get one function working and try to figure out what we're doing. We have a get best my turn. So how do we do this? We do a criterion benchmark. And this is just a name. This is not a really particular thing. It's just criterion group is the question. Criterion group. So, criterion group benches. I don't know where that name comes from. And we're going to say get my best turn, get my best turn. We can fix that later so we don't have to do that. And it takes a mut benchmark and mut criterion. And criterion also has an iter function, so that makes it easy. Then we need a criterion main benches. Let's see what happens if we run this now. Let's just run bench. Failed to parse manifest. Okay, why did it do that? I don't know why there's double brackets here. Let's just assume there's not supposed to be double brackets. No. Can't find my benchmark. Specify bench dot path. What am I supposed to run? Oh, there it is. Miss. Alright. It's installing lots of stuff. We can also just avoid using the benchmarker from Rust and then just make a program and run that instead. That's another option. We can just... Wow, this downloads a lot of stuff. So what it means is we don't have to do benchmarking. We can just make a main program and call it once, and that gives us better control. But hopefully Criterion gives us better control as well over the default benchmarking. Because this profile bench here does nothing. While this is downloading, let me take a really short break, and I'll be right back while it's downloading. Alright, did we finish downloading? Oh, we have a build failure. What do we have wrong? You could try the macro criterion group. I spelt it wrong. Wonderful! Criterion. That makes more sense. Now let's see what... no method named iter. Well, that kind of sucks. Bench function. Why do I have to do both? Well, this setup criterion kind of more overhead. Right, this is a bit more set up than the other one. But the other one doesn't let us do what we want, so it's really not that much of an issue. Oh, why did I call this benchmark function? I wonder if there's an easier way to do this. Because this is more set up than the other approach. Bench function. Come on. Oh, now they're just pissing me off. Alright, we're gonna do this way. We're gonna... No, we... Whatever, we're just going to do it this way. We're going to stick this right here, and just stick this whole thing in here, and stick that at the end. It's compiling a lot slower too. It's kind of annoying. Alright, so how do we open this? We're calling benchmark function here, and that creates a function, and that creates the end of the function. It's beginning to look like JavaScript. Way too many closing things. Oh, it looks like we didn't get an error this time. Its output is a bit... It's calling it lots. That's fine. Is it ever going to stop calling it? Let's get rid of this print line. No, that should be there. Come on, criterion, let's get rid of the print line and run it again. Collecting 100 samples in 68 seconds. Why the hell are you doing 5,000 iterations? I mean, there's got to be a way to reduce that. How do I reduce this amount of times it's called? Alright. We've done nothing in that time, cries. You ate quickly, but, how can I run this less? I want to reduce the amount of times it runs. Alright, how long does this take? Get by this turn. And this is also running in release mode. How can we get this to run in debug mode? Debug. Come on, run in debug mode. So it's the exact same problem. Yeah, I've got Criterion set up, and I can't figure out how to run it in debug mode. So it's the exact same problem we have with benchmark. We can't run in debug mode. Does this make a difference here? This is supposed to be 0 up here. None of this stuff here works, so we can ignore that, but no, it's too slow. Cries, it is not. We verified that this makes no difference on benchmarks. It's simply not using these settings here. It didn't matter what value we put here, the times we get out for opt level were the same in benchmark. And you can even see here, it's released, it's using the optimized targets. And that was the same with the normal benchmark. It's simply not using, we don't see a way to actually run this in yeah, that's odd, and it's not very nice. We don't like that. So, Criterion or otherwise, we see no way to run benchmarks in debug mode. And Criterion has the problem that does a lot of iterations, and I see no way to control those iterations. Cries, can you show me where the documentation is? Because we found an issue where basically that's just ignored. One of the issues we showed, it just always uses release mode. I don't remember which one that was, but there's definitely it. I'm just going to undo the Criterion stuff for now because I'm not happy with that either. Well, maybe this is it. Maybe we shouldn't be using profile.debug. Maybe we should be using profile. No, it's definitely not using that. Let's try another one. I'm going to undo the Criterion stuff for now, or maybe let's see if it uses that first of all, because this is also using release opt level. We can do profile dot. Let's see dev if that makes it use something else instead. Yeah, I was going to check that next, Christ, and see what it is. So, the release. I hope that rebuild. Looks like it's taking longer now. But I have to find a way to change how many times Criterion runs, because this is too many. Oh, that's the wrong voice. Yeah, so it does not use those other settings. And if I was doing a real project, this would be an issue that I couldn't run profiling in a different mode. Because profiling always, or maybe profile, who knows? I don't know why it doesn't use that. But clearly it's not using profile bench. The documentation is clearly wrong. It does not use profile bench. Now, how can I reduce the number of times this thing runs? Well, they're not being helpful then. Alright, so we actually forced to recompile, so it's just doing that now. It's slow. But we need a way to say... Yeah, look, though this is definitely slow now. This is definitely running in the slow mode. But does anybody have any idea how to get Criterion to run less iterations? Because this is too many. I'm not going to sit around and wait 5 minutes for each iteration. That's just ridiculous. But I don't see anything in the guide that says that. Rust Criterion iteration count. But I don't even see the API for Criterion. There's like, I'm missing an API. It's just a book. I don't want a book, I want an API. Oh, here it is, Bencher. Criterion main. Yeah, I think I got it now. Thanks, though. Criterion group. Changes the size of the sample for this benchmark. Well, I'm going to cancel this nonsense. I don't know what this iteration count is. I don't understand why it says collecting 100 samples from this number of iterations. It's like doing like a significant... And what is this? This is a... I don't know what this is. How do I get to this function? So a bencher. A bencher is... We have a criterion. What is a criterion? Let's go back a step. Let's do a sample size of 2. The hell was that? B dot sample size 2. Cannot move. What are you talking about? Cannot move out of borrowed content. Why does it return itself? That's like the wackiest thing. Cannot move out of borrowed content. I don't know how to call this function. I do not know how to call this function. Am I maybe supposed to just take it this way? Did I get that wrong? Well, I have no way to call it then. There's no way to actually call this function because I don't own it. Now, I'm pretty sure I'm supposed to take the one that's called the function, but well, I just really don't know how to call this. Well, do I have to do this other stuff? Well, maybe I don't have to do the other stuff. Will we just get rid of this nonsense? Bench function and... Oh, but this is weird then with the calls. Oh, man. Oh. Usability is not a good thing in the criterion library because I can't migrate easily. And bencher. Fine, that's a bencher. Let's put that back to bencher. That was actually a clearer migration. And let's get rid of this so we don't need that bit anymore. That's a bencher already. We're going to let it iterate. Get rid of that. Get my best turn. Get my best turn. Default, that's sample size 2. Well, this is supposed to be a sample as well, but it also doesn't like this. Where are we? Where are we? But I want to do this other way now, because this other way is simpler. But the other way doesn't work, so... Okay, I don't know. Compact form. Well, let's go back to the other way then. Let's go back to that way. So we do criterion group. And this takes a weird syntax. Yeah, I'm getting that. So name equals benches. Config equals criterion default.sample size 2. Targets equal get my best turn. I think. I don't know anymore. No, that's, and there's nothing there. And that's supposed to take, oh, and then we have to set that up. We have to go back to that. But this now takes, no, let's just do, let's set this up this way. This takes whatever it is, a criterion, and calls a c.bench function get my best turn on get my best turn. And we need this one back because crisis. No rules expected the token. Can I not put a, I probably can't put a lambda here. C get my best turn. That's really crappy you can't stick a lambda there. This is getting really annoying to use. And mut criterion. Well, because you can't call a function that takes a bencher. You need to call a function that takes a criterion, and then the criterion can call the bencher. Yeah, the wrapping is weird. I don't like the fact that you have to double wrap the functions. You make a function that takes the criterion object, which you're not actually allowed to modify, and then you have to call a bench function on it. So it's a complicated setup, and this wants a criterion bencher, I think. Alright, so that looks good. That looks like the actual setup we want. And we're going to get rid of the warm-up time. So 2 samples, it still does 12 iterations, which is really annoying. But we can clear up the other stuff now. Now, so this has these options. It's really... It's hard to set up criterion. It's overly verbose. You have to set up a main. You have to do this criterion group, and you have to give it a function which takes a criterion, and then you have to give it a criterion which calls a bench function. It's overly complicated for what we want to do. Warm up time, I really want to do really like nothing. I don't even know what it does. Warm up time, let's just do 0.1. Oh, and it expects a duration. What the hell is a duration? Let's just do 100 millisecond warm-up. That's not going to help us anyway here. Yeah, maybe it's because Rust doesn't support another one, but it's still... The main part I understand, but I guess the thing is that it has no way of reading stuff like this. There's no way for it to create these types of things. That's unfortunate, but... Use standard time duration... Yeah, that's what I... No, Christ, I didn't mean to contradict you. It's just... I just said it a different way. I don't know what is running here. It's kind of stuck in this result. And... Oh, come on! Its plotting doesn't work, apparently. All points y evaluate. So we can't use the plotting, but it is by default. And I'm not liking the output. I'm just like, it's really messy here, and it's because of this error. There must be a way to turn the plotting off, because it failed. So 436 milliseconds, but at least we get a proper value now. But we probably could have done that with the normal benchmarking tool. But let's keep with this for now. Let's figure out how do we turn off plotting. plot, 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 plot. Without plots, because it doesn't work. Without plots. And let's see what happens now. Alright, so that gives us a decent output now. Part of the reason we wanted to use this though was for the plotting, so it's kind of unfortunate that the plotting doesn't actually work, because GNU-plot is installed on my system, I think, or GNU-plot, yeah. And so it just appears to just not work. There's something wrong with it. But we get this output, so now we clearly see that we're taking 435.57 milliseconds, which is obviously really pathetic. And that's with the search depth of 3, and this would be enough to trigger it because our timeout is only 100 milliseconds. So 2 milliseconds, if we put search depth of 2, we're going to see what we get. And so this is all that's so far set up. We haven't actually managed to maintain anything. And so this goes down to 90 milliseconds. And so this is why with 2, we barely actually managed to get something working. And we also changed this thing up here on iter best move, iter best turn. We enable these bombs again. We're going to disable them again. We're not going to do any bombing on the iterations, and we'll check how long it takes us. Because that's what was causing us to actually occasionally time out at a depth of 2. And so that's significantly faster because that's basically breaking down the branches down once more. And we could probably go up to 3 here now with 17 milliseconds. But let's do the one step we thought might help. We have we're going to have to create a pool of these states to reuse them. But if we just reuse it once, like at the top level here, at the iteration level, there's 5 offsets here. There's 4 offsets. So if we reuse something at least once, or at least twice, that should be enough. So let's do that. Let clone equals state.clone. And actually, we're going to put loop dupe state here, dupe state. And this isn't a very good optimization, but we should at least see something. Dupe state dot better clone, whatever I call it. Better clone from. Better clone from state. Alright, and we can actually put this at the... Yeah, we'll figure that one out. This should be enough to show an improvement, because we're using a better clone from, so we're at 17 milliseconds. So let's see what happens if we run it now, if we don't get any errors, of course. Let me dupe space. And I dropped my pen. Okay. Well, let's see what we're at 17, and we're at 19. Well, that sucks. How on earth did that go down in speed? This didn't make enough of a difference. Huh. Why? If not first. Alright, so we don't really have enough iterations here. This would mean that overall, the cloning of the state, although really costly, isn't what is costing us the most inside of here. So we're going to have to look at what is actually costing it. Now, I don't know if we have any actual Rust profiling tools. Benchmark is a minimal one. We would really love to have a full profiling that tells us where the time is spent. I don't know if we have that. Is there an actual Rust profiler? Profiling code in Rust. Profiling tools for Rust. Well, Valgrind might work. Alright, so Valgrind should work. And what do we want to do? We want to run, what do we have? We have output here somewhere. Well, I'll look at what Flamer is, but I mean, if Valgrind's going to work, I'm familiar with Valgrind. What does this do? No, this is for targeted. I want something like Valgrind right now, which does absolutely every function. And let's text that one. Where do we have that? But it seems to print a graph only of the things you've marked. Right, this is only of the things you've actually marked, whereas Valgrind checks absolutely everything, every single function call you've made. It checks everything. So let's look in target. Well, now this is probably release. And what's all that crap in there? Alright, let's just well, let's figure out Valgrind, or this first. Let's do RM. I should just remove that whole damn target directory. And run the benchmark once. Fine, you can compile that again. So much for improving our code. We're still trying to measure it. We're trying to measure our code. We're trying to figure out where the speed slowdowns are. Criterion took a lot of time out. Criterion's actually... It's not overly complex to set up, but their docs don't say how to set it up correctly. We had to jump around, and Cryos was able to find it. So if somebody from Criterion's watching, please fix your intro docs to just show how to set it up correctly. And that would help a lot. And figure out what the plot error is. And now we're going to figure out how to use Valgrind, and we're going to use callgrind, Valgrind, callgrind, and then we're going to look at the graph of where it is. Alright, so we're going to do Valgrind, that says tool equals callgrind, target. I hope this has debug information. Main. No miss. Like, look at these wacky names it's creating. Alright, let's see how long this takes to run. Could be a long time. Well, it's usually about 10 to 20 times slower than like running it directly, and it was taking 5 seconds, so that could take up to a minute. Okay, we did add debugging memory. That's good. Debug equals. We put debug. Oh, I changed that. Damn it. Oops. Shit. Well, maybe it still has it may still have function names in there, because when you build a non-release mode, a lot of the functions still survive, so it should still give us an idea, hopefully. And I'm just worried about it getting stuck inside the actual benchmarking code. We should probably make an even cleaned up target. If we're going to run Valgrind, it makes more sense to run it, not to use a benchmarking tool, but to create our own target, call the function once, and then look at it that way. Otherwise, we're suffering the overhead of the benchmarking tool, like this analysis stuff. We're not going to see where that is, but it should be enough anyways. Then we'll run a tool called k-crash-grind on the output, which lets us visualize what we have as the output. And this analyzing, this must be really complicated because this is taking way too long for Valgrind. So Valgrind is spending a lot of time here, so we're going to have to write a separate program that gets rid of it. And that's okay. But you notice that RLS turns on and off? So there must be has to do something with the targets generation is screwing things up. And you can see this call grind out being generated. This is the output file it's creating, and that's the one we're going to look at to see what's causing all this time delay. And now this is really a problem now that this is taking too long. The analysis phase of the benchmark is just taking too long. So when we do k-cache grind, it's most likely going to be the benchmarking tool that has all of the execution. But we should be able to narrow down the graph a bit and see where it goes to anyways. Come on, come on, come on. Thinking. I'll think slowly too. Yoga think, yoga think, yoga, yoga, yoga think. Alright, and this is what you'd expect. It takes a long time. Now Valgrind keeps running, and Valgrind is not fast, but that's not what it's there for. Valgrind does a CPU simulation, and you see it collects all these events. So now we're going to do a k-cache grind on call grind, and I hope I got this right. There we go. You probably can't see it. Let me change the size of this a bit. Oops, I did the wrong damn window. Did the chat window. Why is this maximized? There we go. Alright, so we have a call graph here. And you can see where all the time is spent. Probably in here somewhere is a function called... Yeah, what do we have? Where's the one called the most? So we have a lot of slices. So you can clearly see here something in Rust itself is taking a lot. Mem size, null, a slice merging is taking a lot of time. We disabled our debug information, so it might be hard to find in here. So let's just look for get my best turn is called 3 times. And now this shows you the massive overhead inside the profiling tool. It called it apparently 3 times, and it only accounts for 5% of the total time. But we're just going to keep debugging down in there and see where it is. If we get down to iter best turn. Alright, so get best turn. Iter best turn 5.5, and this is where you see the breakdown here. This is how these tools work. So we're getting inside this function, and we can actually make this one. So get my best turn. We're going to start here and graph. We want to visualize. We want to start at this one. How do I start at this one again? Whatever, we'll make it relative to that. No, I should be able to make it. I haven't used this in a while. Well, that's weird. Whatever. So we call it 7 times, but over here it only said 3, which was weird. But its sampling is weird in any case. And so what we'd like to have is relative to this, and I'm positive you can do this, but I thought you could do this. Alright, let's just look down anyways. Let's look further. No, I want that to work. I've forgotten how that works. You're supposed to be able to say, let's start here. Come on. Yeah, this is demangled. K-Cache-Grind is pretty good at that. I just want to figure out how I set the depth starting from here. Whatever, let's just ignore it for now. So what we do is we say this is 5%. So this function, iterBest, takes all the time. And then you can see how it spends its time. Apply turn isn't very much. Apply turn takes a little tiny bit of time. So apply turn we're fine with. Likely die. Likely die is an expensive function. Now we have step state, which is also an expensive function, and get score, which is a function. Yeah, it's going to fail on some. I don't care about that. But yeah, right here, less than. Yeah. These are template functions from C++, or I guess also Rust. Maybe it doesn't know Rust. Maybe in C++ it would demangle that. So this function here, we should be able to see visualization tall. All right. So a lot of the time spent there. But see, we have no low climb flute. Step state is slow, and this is something we could fix. So step state's pretty slow. And you notice clone isn't coming up anywhere here. All right, we can go back to here and look for strategy. And you can look at it this way as well. Is entity within range is the most expensive function we have. And so this accounts for 0.09% of the total time. But sometimes these numbers can be misleading. But it's definitely the highest one. It's the function that costs us the most, and they drop pretty fast. And boxes within bomb range also calls it. And so those are the really expensive functions on here. I wonder if clone even shows up anywhere. Clone, state. Clone doesn't seem to be taking much time, so it's... Get my best turn, then iter, likely die is the next best one, then get score. Boxes within bomb range is probably the biggest one there. Hi, Moderated Seal. Welcome to the show. We're doing some profiling of our code here. And alright, so we have like no easy low-hanging fruit. We just got to target all of these. We have iter-best turn, obviously, but it doesn't spend much time in itself. And this is what the self score is. It calls it a lot, but it takes a lot of time, but itself doesn't cause it because it's calling out to other functions. And get score is pretty expensive. But where does all the time actually go to? All the time, this is the self score generally, is entity within. It counts for a huge amount of the time. And a lot of this is going off to right. Okay, this is why you have to be careful of self, because this self excludes the core Rust stuff. And so this iteration is taking a lot. So if you look at the inclusive score, we know get best turn. These ones we can't do anything about. Likely to die is the first candidate for saying, hey, look, likely to die is too slow. And the next one is get score. So likely to die and get score are very awful. These are very expensive functions. And then boxes within bomb range. So I'm going to write these down so we don't have to keep running this again. But we should run a more isolated test here too. We should set up an isolated one. But I think I'm going to be done for today anyway, so I'm just going to write these down. The ones we should be targeting are likely die, and get score, and boxes within bomb range. So the state duplication, the state cloning, while slow, apparently doesn't come up high enough in the list. But you never know, because it could be one of these things up here. It could actually be like the get best turn could be caused of it. And create bomb map is expensive. But we can probably work, and then there's is entity within range. Is entity within range is probably a good one to fix, because it's called so much. And then from there it drops. Distance 2. Distance 2 is another big one. Those are our biggest ones to look at right now. Those are our low-hanging fruit, what's in these. The top level 3, probably not. And these ones down here. And that's okay. And now let's look for state. We have state functions here. I wonder if we have a state clone. Clone or better? Let's look for better. Better clone. Now, better clone does account for some of the time, 0.28 of the total time, and we're in a total of 5. But it's a very small part of it. And we've already did that one optimization to help it a little bit, but it looks like it's simply not high on the list of things we have to optimize. So we're going to get back to that afterwards. After we do get score, boxes in bomb range, create bomb map. And we're going to have to do a little bit of setup here, creating the main. I might do that offline, set up the main so we can call this benchmarking a little bit more often. I'm not so happy with criterion. Something's generating a lot of junk in our tree. And that's okay, let's put this in the background. Right, our target here, we're in release mode even though we're turning off debug, and it's really weird. And it's creating these files called miss with a big ugly name. So I don't know, maybe we can keep criterion. It has decent output, but weird setup. I think that's all for me today. We're going to set this up because I wanted to get into more of the optimization today, but it took us a long time to get the tools and stuff set up. Knowing Valgrind works is going to be our best option for profiling. If you don't know Valgrind, it's like your #1 friend for profiling executable code, and it helps you find the spots that are slowed down. It doesn't require any manual marking. It just takes an executable. Yeah, I'm not, yeah. Okay. So we're not going to blame criterion for these, but something's not deleting them either. If you saw below, we had a lot more of them. Oh, they're gone now. And we'll figure that one out. 'Cause, yeah, I guess it's Hypersonic is also a main. Big ugly names in here. Rust loves generating lots of stuff. Cargo generates lots of stuff here. I mean, if you have the space, it's not a problem, but it makes it hard to run these things. It's kind of annoying if you don't have a clear name. So what we're going to do is we're actually going to create a separate program, not the benchmarking program, a separate one that runs a few iterations of the game, And then we can actually use the benchmarking tool again, the profiling tool of Valgrind, to figure out where is it taking so long with a lot less overhead. And we'll go from there. So, sorry we didn't get very far. We didn't manage to actually do anything in here. Our robot's still sitting at 109 despite the fact that he times out, which is really weird. So occasionally it probably does alright. And I won't be doing Evening Rush tomorrow, but I hope maybe during the day or in the evening I'll do a Leaf, the Wormies programming. I can quickly show you some Wormies stuff that we've been working on. And this is for my programming language. It's obviously the interesting part isn't the video game. The interesting part is that we're doing a language, /leaf/wormies and distribution leaf. And it has a long command line. I should probably stick this into a makefile or something. SDL2 image library SDL2 TTF library GL lib and wormies. So this is the game I'll keep working on tomorrow as an alternative to Rust. This is the actual... It's a simple game. If you recall when we did Tron, this is basically based on the Tron game, and I wanted to do this. I'm going to set up in the stream. I'm going to show you how these algorithms work, how we do the filling, how stuff moves around, and importantly, how the computer player works in a Tron game. And we're working on the code for this. And again, the interesting part isn't obviously the game itself, but the fact that we're doing it in my programming language called Leaf. And that's the compiler that does all of it. And we're using SDL and GL to do this. So I'm showing all the basics of a game setup as well, how you do basic sprite maps, how you can do movement, and how you do basic animation, how you use GL. So a lot of stuff we're going to cover in that show as well. And I'll do that probably tomorrow at the same time I started this one at 6, or maybe during the day, depending on whether I feel like going to the gym or not. And so this is just some other aspect we'll do on the show. And I just let myself die here, and I run into the monster. There we go. So that's for that show. We're looking at a lot of different things. And then Evening Rust. Again, I'm working on a new schedule. I'm not clear. Saturday night I don't have time. Sunday night I don't have time. So otherwise, it would probably be next week again. Maybe Wednesdays and Thursdays are decent nights for Evening Rust, and the weekends when I have time. And during the week, I might start another show doing more computer science-y type stuff, algorithms. But it's open. If you guys have times that are good, just let me know. And just make sure you follow me on Twitter and stuff, as my audience is going to be weird. Follow me on Twitter and on Twitch, and I'll always announce when I'm going on live. And I thank you for watching today, and we'll see you next time.